What's up guys, I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we are going to look at an overview of the machine learning process. So as you can see, I do have this split up into two articles, so we will cover both in this one session. Okay, so let's get started. Now, you see, to help you get a better understanding of the machine learning process, it can be summarized in a simple four-phase flowchart, okay? 4 steps, 4 simple steps. We have as the first step, data preparation. For number 2, we have algorithm selection. For number 3, we have model compilation. And for number 4, we have the prediction/evaluation stage, okay? Now, as you can see in the above diagram, right, this flowchart diagram here, there's 4 major steps involved during any typical machine learning process. So these steps that I've listed here, they are the generic, okay, the generic steps that you have to follow when, performing the machine learning task. Like under data preparation, for example, there's a lot of other sub activities or processes that can go on behind the scenes. Okay, data preparation is kind of like the encapsulation of all the necessary steps that you need to take in order to get your data prepared for the algorithm itself. Now, the explanations of these steps are actually explained in the next post, right, which we will cover in this one sitting. So, you see, from my personal experience with machine learning, the data preparation phase is most important, okay? The others are not difficult at all. Data preparation, to some, it can be confusing. That is why there is kind of an emphasis, especially in data science and machine learning, that you know how to, handle your data and work with your data. Because let's face it, in the real world, data is hardly ever cleaned, guys. It's always dirty, and there's noise, and there's outliers and anomalies and so on that exist inside the data itself. So let us actually look at the explanation of these steps themselves. This will enable us to understand the machine learning process on a much higher level. So let's get to it. For number 1, we have the data preparation stage. During this stage, the data is prepared for the algorithm. Data needs to be carefully handled before being sent into a machine learning algorithm, okay? In the same way that we require food to be cooked before consumption, an algorithm requires its fuel, data, to be carefully prepared before being fed into it, okay? Simply put, the nature of effort invested into perfecting the fuel, the data, for the algorithm will have a direct impact on the computational power or predictive power of the model and the quality of predictions. Because you see, guys, the data on which the model is trained determines how it will make predictions for the rest of its lifespan. Okay, so this is exactly why the data preparation phase is one of the most crucial. Okay, because what I feed into my algorithm in this data preparation session, it's going to determine how my model performs for the rest of its lifetime. So if I basically invest a whole lot of time into perfecting this data, I'm making sure that this data set that I'm working with, it is completely clean, it is exactly how the algorithm requires it to be, then obviously I'm going to get a model of highest performance, okay? I am maximizing the optimization levels of the model output. Whereas if I, do the complete opposite, so I do not cater for maybe outliers in the data set, I do not care to remove noise from the data set, I just feed the algorithm the data as is without any cleaning operations or preparation operations, the model quality is going to drastically decline, guys. So keep that in mind. Now, during the preparation stage of the data, one is required to select the feature that one would like to predict, called the target vector. So you guys should realize by now the reason as to why it's called a target vector is because a vector is a one-dimensional array and given the fact that, you know, the column that's being predicted is a one-dimensional column, it is in essence a vector. That's why it receives the name target vector. And anyway, the feature that we'd like to predict is called the target vector, and we need to set it aside from the features that will be used to predict. And those features that are used to predict is called the features matrix. And you guys realize now again that a matrix is a 2D or more D array. So hence, the greater the quantity of data, the better the quality of predictions. This is because the training process spans a longer duration, thereby impacting the level of insight obtained during the learning process. A good example of data preparation would be deciding how to handle those rows in which a field has missing values. Do we delete those rows entirely? Do we fill the missing values with the average value in that specific column? So that is number one. Now I'd just like to pull you guys back to this portion here. You see, this is quite important, guys. That is very important paragraph of text right there. You see, this machine learning is very similar to the way in which human beings learn, right? So regarding this paragraph that's highlighted, it's the exact same logic as saying, if I give maybe a 3-year-old child, you know, maybe if I daily show a 3-year-old child images of cats and dogs, and if I do this for maybe 6 months, the chances of that child, 3-year-old child, knowing the difference between a cat and a dog when they are 4 years old is going to be greater, as opposed to maybe showing a 3-year-old child images of cats and dogs for only a week. Okay, so that is basically logic there. The more data you're showing the model, the algorithm itself, the greater the chances of optimization. Okay, I wouldn't say perfection, because perfection doesn't exist. Okay, in nature and in every aspect of life, perfection does not exist, but optimization can exist. You can maximize your output. So that is fine. Now, number 2, the algorithm selection stage. The algorithm refers to the particular methodology that you will select. The algorithm is that component of the machine learning framework that does the learning. Okay, now it is very important, guys, once you understand that, you see, oftentimes the people say that the model is what does the learning. Now the model does not do the learning. The algorithm does the learning for the model. Okay, the algorithm learns, and the output, the finished state of the algorithm, is what we call a model. I've explained this to you guys. Okay, it's the same as saying we take a graph, a simple straight line graph, y is equals to mx plus c. That's the algorithm. The model is when the algorithm has completed the coefficients or the weights. So from y is equals to mx plus c, that's the algorithm. The model can be something like y is equals to 5x plus 10. That's your model. That's your finished state of the algorithm. Okay, now when the algorithm is exposed to or applied to the data set, it's going to analyze each feature and attempt to learn trends and patterns in the data set itself. It's good to understand that the type of algorithm that one selects for the task at hand is dependent on the nature and type of data that you are working with. Okay, there are several categories and types of algorithms. Some categories include regression, classification, and clustering. Some types include linear regression, logistic regression, and the Birch algorithm. Okay, now we will explore a variety of algorithms in detail at a later stage in our journey together. Now, as much as I am reading this line from the post itself, it does apply to the YouTube videos as well, guys. I have a massive amount of content planned for the channel, and at this stage all it can do is reside in the plan stage. So as time goes on, I am going to dedicate time to recording my tutorials for you guys, and we can work through those together. Now, on to number 3, the model compilation stage. During this stage, there are essential training events that occur. You see, most, if not all, algorithms can be represented as a mathematical expression. Now, this is a line that is very important as well, guys. Always keep in mind, whether you are involved in data science, deep learning, machine learning, and so on, every algorithm, it has the ability to be expressed in pure maths. Now, we don't see the maths often. Why? It's because the computer does everything for us, okay? If we work with Python machine learning, the chances of us manually taking pen, paper, and solving the, machine learning algorithm first, it's low. It's very, very low. In fact, I've never heard of anyone who who does machine learning manually using pen and paper. Okay, in this day and age, everything's done by the computer, and for good reasons too, because the computer can handle much more computations, in a shorter space of time than we can. So that is fine. But keep in mind, mathematics and machine learning work hand in hand. You see, every algorithm can be brought down to a base form, and that is in the form of simple variables and so on. A mathematical expression or equation. Now, the model is successfully compiled and completed when the algorithm has successfully found the best, most useful coefficients to use in the formula. Okay, think of a simple line graph. So I've explained this to you. F of x is equals to mx plus c. During the model compilation stage, the model will attempt to find the most suitable coefficients for m and c by applying the algorithm to the data. Remember that the algorithm does the learning. The model can be thought of as being the memory during the training process, which remembers the teachings and stores it for future use. As the model finds suitable coefficients, it gradually builds up, bigger, better, and possessing higher predictive power. Model compilation is completed successfully when you are able to use the model itself to make predictions on test values. So, for number 4, we have the prediction/evaluation stage. You see, guys, before we conduct a prediction using test values with our model, we should always proceed to evaluate the model's predictive power. Now, the evaluation of a model gives us, the human being, insight into the accuracy and usefulness of a model. Because logically speaking, a model is only as useful as its worst prediction. Okay, guys, so you see, evaluation of a model is done using evaluation metrics. Now, these are specific formulae. Again, they can be represented in formulae. Okay, so using variables and so on. Now, these formulae, evaluation metrics, they are applied to a model. And this is done to test and see how accurate the predictions are on data that it has never seen before. Okay, now, so before we actually wrap up this video, guys, you may be wondering, why call it the prediction and evaluation stage? Now, I've specifically merged these two together because, you see, it is very good, in my opinion, it is very good practice to first evaluate a model and then conduct predictions. You see, why I say this is because in machine learning and data science itself, right, I've never really encountered a situation in which a complex model has attained 100% accuracy. It is for this reason why I say, you see, first evaluate the predictions and then conduct predictions. Now, the reason for this is because it's going to give us insight into the margin of error that the model is making. So when we obtain a output or predicted value from the model, we can tell now that, I need to cater for the margin of error. So I need to add maybe this much values to accommodate for variance, and I need to subtract that much from the output value that it has given me. So that is fine. Now this concludes the overview of the machine learning process. In the next video, we are going to look at a simple machine learning example. Okay, so I hope you guys found this session interesting. Do be sure to leave a like for this video, guys. Comment down below if you are finding these sessions enjoyable, and please subscribe to the channel. Apart from giving me a boost in my motivation, the YouTube algorithm really likes to see those statistics, and so it will push my video out to more such aspiring individuals like ourselves. So with that, thanks for your time, guys. Good luck with your work, and I will see you in the next YouTube video.